Section 11.6, Solving Rational Inequalities. So solving rational inequalities is almost identical to the previous section, section 11.5, solving quadratic inequalities. So let me do on page 494, problem number 2, x plus 2 over x minus 3 greater than 0. So just like in the previous section, we want to put this into standard form, factored standard form, and well, it's already in a simplified standard form. So let's determine our critical numbers. So the way that we determine critical numbers in this case is we set each factor equal to 0, x plus 2, and x minus 3 equal to 0. So just like in the previous case, the only time that these rational expressions can change sign is at the critical numbers. And so subtract 2 from both sides, add 3 to both sides of my equation, and so I get x equals negative, x equals negative 2, x equal positive 3. So those are my critical numbers. Place those critical numbers on my number line. Negative 2, positive 3. Let's take a number between negative 2 and positive 3. 0, that's the easiest. The sign of x plus 2 when x is 0 is positive. The sign of x minus 3 is negative at x equals 0. And so positive divided by negative is negative. The root at 3 is simple, has a odd multiplicity, so it changes sign. The root at negative 2 is also simple, so it has multiplicity 1. So again, it changes sign. We want this to be greater than 0, and so I just fill in what's under the plus sign, what's greater than 0. Since this is a strict inequality, I will leave each of these critical numbers as open. And so it is the open set. My solution is the open set, the union of the open intervals, negative infinity to negative 2, 3 to infinity. And that is the solution to my inequality. How's 3 positive again? Okay, so you take a number greater than 3, let's say 4. The sign of x plus 2 at 4 is positive. At x minus 3 is also going to be positive at 4. Positive divided by positive is positive. Or we could see that since at x equaling 0, this rational expression was negative, then since the power of the root, notice we just have a power of 1, there's no power, there's just a power of 1, and since 1 is an odd number, then that means that this sign will change when I cross the root. So it changes from negative to positive. And so looking at it two different ways, you can see that the sign here will be positive. Okay? Let me do problem number 8. So let me do problem number 8. Negative 4x over x minus 3 is greater than 3. So in this case, it's not in standard form yet. And so I will subtract 3 from both sides of my equation, my inequality. And so I have negative 4x over x minus 3 is greater than 0. Let me write, the only way to combine these is to get a common denominator. So let's multiply and divide by x minus 3. The common denominator is x minus 3. And so let's multiply the negative 3 inside the parentheses. And so I get a negative 4x over x minus 3 plus negative 3x plus 9 over x minus 3 is greater than 0. And so now let's write this all over the common denominator, x minus 3, and combine like terms. Negative 4x minus 3x, negative 7x plus 9. And so I have written the inequality in standard form, and its factors as much as possible. Therefore, I can now determine my critical numbers. And so let's determine the critical numbers. To determine the critical numbers, I set each factor equal to 0 and solve for x. Subtract 9, add 3. And so I have negative 7x equals negative 9, x equals 3, divide by negative 7. And so x is equal to 9 over 7. And so I have here two critical numbers. So let me place those on my number line. Nine over 7, 3. So again, this partitions my number line into several intervals. If I take a number less than 9/7, say 0, then the sign of the numerator is positive. The sign of the denominator is negative. Positive divided by negative is negative. Since the root here for the numerator is 1, it's a simple root. So the multiplicity is 1, an odd number. Therefore, the sign will change when I cross this root. The root 3, for the root 3, the exponent is 1. It's a simple root. Therefore, the multiplicity is 1, an odd number. So positive changes to negative. We want this to be greater than 0. And so I fill in everything below the plus sign. There's no equal sign, so I do not fill in either the critical numbers. And so my answer is the open interval 9 over 7 to 3. And that is your answer. Let me do problem number 11. Three over 2x plus 5 greater than or equal to 2 over x minus 3. So let me subtract. So again, this is not in standard form yet. So I have to make the right-hand side of my inequality 0. So let me subtract 2 over x minus 3 from both sides of my inequality. And so I get 3 over 2x plus 5 minus 2 over x minus 3 is greater than or equal to 0. So in order to combine these, I need a common denominator. So the least common denominator in this case is 2x plus 5, x minus 3, 2x plus 5, x minus 3. So let me multiply and divide by x minus 3. Let me multiply and divide by 2x plus 5. Let me multiply 3 inside the parentheses, negative 2 inside the parentheses. And so I get 3x minus 9, negative 4x minus 10. Combine like terms and write this all over the common denominator. 3x minus 4x is a negative x. Negative 9 minus 10 is a negative 19. And so I have this in factored form, in standard form, and completely factored. So let's determine my critical numbers. Let me set each factor to 0 and solve for x. Negative x minus 19, 2x plus 5, x minus 3. So add 19 to both sides of your equation. Subtract 5, add 3 to both sides of your equation. So I get negative x equals 19, 2x equals negative 5, x equals 3. Divide by negative 1, divide by 2. So x is equal to x is equal to negative 19. X is equal to negative 5 over 2. X is equal to 3. So let me place those 3 critical numbers on my number line. So negative 19, negative 5 over 2, positive 3. Okay, so let's take a number between negative 5 over 2 and 3, 0. The sign of negative x minus 19 at 0 is negative. The sign of 2x plus 5 at 0 is positive. The sign of x minus 3 at 0 is negative. Negative divided by positive times negative is positive. And so at 3, well, the multiplicity of the root at 3 is 1. So therefore, so it's a simple root. Therefore, it has odd multiplicity. And so when I cross the root, it will change sign. The root at negative 5 over 2 also has multiplicity 1. It's a simple root. So since it has odd multiplicity, then again it will change sign. The root at negative 19, again, is a simple root. It has multiplicity 1, odd multiplicity. So again, it will change sign, plus. Now, we're supposed to fill in, this is greater than 0. So I'll fill in what's below the plus sign. What's below the plus sign? It says greater than or equal to. Oh, so it could be equal to 0. And so, since it says equal to 0, then I'm going to fill in every critical number except for those found by setting the denominator to 0. So I do not set negative 5 halves nor 3 to 0, because if I did, I'd be dividing by 0. So these critical numbers are not filled in, but the critical number found by setting the numerator to 0 will be filled in. So negative 19 will be filled in. And so this will be the union of the closed set, closed interval, negative infinity to negative 19, union with the open interval, negative 5 over 2 to 3. So it's a union of a closed set and an open set. Let me do problem number 16. 2 over x plus 1 minus 1 over x minus 2 is less than 1/3. And so let's subtract 1/3 from both sides of my inequality in order to put it into standard form. And so I have 2 over x plus 1 minus 1 over x minus 2 minus 1 over 3 is greater than 0. Let's get a common denominator. The least common denominator in this case is 3, x plus 1, x minus 2, x plus 1, x minus 2, and 3, x plus 1, x minus 2. So let's multiply and divide by 3, x minus 2, which is the same as 3x minus 6. Multiply and divide by 3, x plus 1, which is the same as 3x plus 3. Multiply and divide by x plus 1, x minus 2, which is the same as x squared minus 2x plus 1x minus x minus 2. Let's multiply the 2 inside the parentheses, the negative 1 inside the parentheses, the negative 1 inside the parentheses. And so I get 6x minus 12, negative 3x minus 3, negative x squared plus x plus 2. And so, combining like terms and writing everything over the common denominator, I get negative x squared. 6x minus 3x is 3x plus x is 4x. Negative 12 minus 3 plus 2, negative 13, is greater than 0. Let's determine my critical numbers. Note that the numerator cannot be factored over the rationals. So let's set each factor to 0. Solve for x. Negative x squared plus 4x minus 13 equals 0. X plus 1 equals 0. X minus 2 is 0. Obviously, 3 can't equal 0. If I try to set 3 to 0, that's impossible. And so let's subtract 1 from both sides, add 2 to both sides. So I get x equals -1, x equals 2. In order to solve, actually, let me do that first. In order to solve this, let's change all the signs. And so I get x squared minus 4x plus 13 is 0. And so let's use a quadratic formula. X equal -b plus or minus the square root of b squared minus 4ac all over 2a in order to try to solve this equation. So in this case, maybe I'll do it this way. B is a -4, so -b plus or minus the square root of b squared minus 4ac all over 2a. And so I have here x equals 4 plus or minus the square root of -4 squared is 16. 4 times 13 is 52. 2 times 1 is 2. And so I have 16 minus 52 is -36. The square root of -36 is 6i. So let's divide each of these by 2. And so I get x is equal to 2 plus or minus 3i, but it doesn't really matter. I can't have I can't have a complex root, and so I'll just get rid of that. So let me put my two real critical numbers on the number line. And so, there it is. Let's take a number between -1 and 2, 0. At 0, negative x squared plus 4x minus 13 will be negative. 3, obviously, at 0 is positive. X plus 1 at 0 is positive. X minus 2 at 0 is negative. Negative divided by positive times negative. So there's two negatives, will be positive. When I, at the root 2, well, at 2 has multiplicity 1. It's a simple root. Therefore, since it has odd multiplicity, when I cross the root, it changes sign from positive to negative. At -1, the root has multiplicity 1. It is odd multiplicity. Therefore, when I cross the root, it will change sign to negative. I want this to be greater than 0. And so I will fill in the plus. Since this is a strict inequality, then I will not fill in either the critical numbers. And so your answer is the open interval -1 to 2. Any questions about that? Oh, good. Instead of using quadratic form, can you factor? Oh, that wouldn't work. Yeah. So you couldn't factor because obviously the only time you can factor is if it was, you know, the the discriminant were zero, but in this case, the discriminant is actually a negative number, so you can only factor over the complex numbers, which we don't want to. Okay, so that really finishes off section 11.6. Let me stop this one recording for a second.